morning, friends. Welcome to my channel. In this channel, I'm going to deal with you the concept of the algorithms. So, the main thing I need to concentrate here on the reason behind for studying the algorithm here. So, normally, guys, we need to understand before studying in depth with the subject what it is actually, why it is required, and if it is required, how can be done. So the content I'm going to cover in this session or in this video is what is the mean of analysis, algorithm analysis, actually why it is required, and how it is put in use. So guys, I hope almost all of you are aware of the concept what is an algorithm, right? So I'm going to give you a simple example. The algorithm comes not only in the system implementation. Normally in our day-to-day life also the algorithm are in use, right? So the definition here I'm given is for the algorithm is a set of steps of operations to solve a particular or a problem, performing the calculation, data processing, and automated reasoning of the task. So for example, if we have the problem considering addition of two numbers, so that is my problem. So how I am going to implement it? First I need to take a input, right? So that input is in the form of processing, data processing. Then I need to perform a calculation is nothing but how the sum is calculated in the form of getting the solution for the addition, and then how I am going to automate the task for the given problem, right? So for example, if you want to travel somewhere, right? So how you will travel it directly, you are not implementing if you have to plan for a while, and then you have to take the processing and then the calculate the form of how it is started, where it is started, when it is started, all this calculation you will done, and then you will put for implementation or put for going for the trip, right? So similarly the algorithm, if you want to solve any kind of problem, so the first thing you need to develop the algorithm, so which will avoid the main issue that we are going to get during the implementation of the program. So now here you are looking for the concept as algorithm is independent from any programming language. So for example guys, if you want to have a trip, so you have many other options, right? So you can go by bus, or you can go by what we will call it as train, or you can go by flight. But all these things will not be worried, but the intention of having the trip, that will be remain same. So similarly here, once you develop the algorithm, it will not uh, have a concern with which programming language you are going to apply on this algorithm. So programming language can be C++, Java, Python, everything, right? Any other languages. So it is not worry. Once your algorithm is designed, so it is final that it can be used with any kind of programming language. So now our basic questions are why the analysis is required. So guys, here there are so many different methods we can design to solve a single problem. So for example, I can go for a simple one, that is we need to sort a given set of elements. So what are the ways are there to sort? We can implement the insertion sort, we can go for bubble sort, we can go for radix quick, or so many kind of sorting, but the method of implementing that is different, guys. For a single program or problem, we can design the algorithm in different way, but our intention here is how we can minimize the time of its execution, and how we can minimize the space taken by that particular algorithm to solve a particular problem. So that is our intention. So here my concern is about on the efficiency or the performance. Better performed algorithm is one I need to select where it will compromise with the minimum time or minimum space. So that's why that is what you need to understand about the analysis of algorithm. So okay, so if it is analysis of algorithm means for to identify the minimum time and space, then why it is required, so why we need to have a minimum time, why we need to check for the or apply for the minimum space, and how we will consider it as a efficient algorithm, right? So once that you understood with what is why what do you mean by analysis, then we need to go for the other two questioning, so why it is and how it is done. So friends, before going that, how the algorithm is developed. So guys, you're seeing here algorithm must have a unique name. So for example, you're performing the addition of one number, two numbers and addition of three numbers, and you need to develop an algorithm. Both the algorithm developments are differs, because in first case it is two numbers and in the second case it is three numbers. Then the name of the algorithm to design that, so you have to distinct it from one another. It should not be remain same. So once you are once you are able to design with the proper algorithm, then you should aware of what are the inputs are necessary to execute the program for the designed or the developed algorithm, and what are the output I can expect, that should be clear. So you should not be in a question mark once you design the algorithm, what is the input and what is the output. You should not get a mess up with the input and output. You should be clarified, you should be clear with the set of inputs and outputs that you are going to use in the designed or the developed algorithm. And you know that algorithms are set of steps, right? So set of procedure, right? So in this procedure you should not have the unambiguity, that is you should have a unambiguity in each and every step. So that is step 1 should not refer to the step 2. It should not in the confusion, it should not be in a question marking way. So what is the meaning of the step 1 and what is the meaning of the step 2, that should be unambiguous. Ambiguity is nothing but the confusion between the step 1 and the step uh, should not be having. So it should be well ordered, one first step to second step from the starting until the termination. And guys, you know that almost if you have executed the program, so while executing the program, so the program will not it will not go on executing, it will stop or it will halt its execution in specific time. So that is time, amount of time taken for the execution of the algorithm is also some of the one of the characteristics that should be included in the algorithm, so that we consider as a speed of an algorithm. And next thing you need to aware of, any loops or any kind of decision or any kind of looping statement if you are using, it should be finitely defined, because once you not define properly, that looping statement will execute infinitely without stopping the execution. So in an algorithm, so you should specify those things properly so that it should not run for infinity. So that is an algorithm must end at some point. So that is a property, or the characteristic is nothing but finiteness of the algorithm. So guys, in overall I can conclude with this slide here is nothing but, so you should be aware that the name of the algorithm should be unique, and then you should be aware of the range of the input and your steps of the procedure, whatever you are included in your algorithm, you should have, it should specify non-ambiguity, and it should also able to calculate the speed of the algorithm, and then it should be having finiteness in the algorithm development. So the, for your just clarification properly, so just I am going to have some two concepts here, algorithm and pseudocode. So guys, you are seeing here how the algorithm is specified in this way and how the pseudocode is implemented. Both are performing the same operation. So in the algorithm you are considering all the set of exact kind of the English language what you speak or what you communicate, that is included in this algorithm. And in the pseudocode, so normally it is a combination of both, that is a programming syntax as well as the English or language what we use for communication, that are combined and that can be included in the pseudocode. So that is a main difference in the algorithm. So let me go with this. So here we have taken the algorithm to sort a list, and I think while seeing this you are not able to understand actually so what type of sorting method is used. So guys, here the insertion sort or the selection sort method is used to implement. So this to comment is nothing but the second point in the characteristic, right? So the second point in the characteristic what we have given here, so that is the range of explicitly defined the set of input and output, right? So that is we need to always put in the first two statement in an algorithm what the input I am going to have and what the output I am expecting, and then I will continue with the procedure or the steps. So this is a way how you are going to develop an algorithm, right? So hereafter, so wherever you are going to document with an algorithm, so in this syntax or in this main steps, so you should include. So here input that is and output are using in the form of comments, because it is not included or it is not processing here, only the information. So I am giving it in the form of comment line, and where the computation or the processing takes place, step 1, that is identified in the form of step 1, step 2, step 3 in the way. So here array of list L is given, and that L is having how many elements? N elements. Okay, so output I'm expecting that sorted list L1, okay, so that containing those integer present in L, but it is in the sorted form, right? So these two information I have clarified. So next I will start with the processing. In the processing, the step 1 is keep a sorted list L1 which starts off empty. So here they are taken two arrays L and L1. L is a set of elements already we have read, and L1 is a array that is initially empty, and once the processing starts, so it is going to be filled one after the other. And then perform the step 3 for each element in the original list L, and then insert it into the correct position in the sorted list L1. So if you have 3 element 2, 1 and 3, so in that case, so first you will select from L the first element 2, and then you will try to put in the second list L1, and then you will go for the second element 1, and you will compare that 1 in L1 already existing element 2, and that is compared. So which one is smaller, that will be placed in its exact position by shifting the existing element in L1. Okay, and once you complete with this form, then directly you will return that list whatever you are sorted, and it will stop your execution. So this is an template or the blueprint for your coding the problem in any language. Okay, so keep a sorted list and then perform the step 3, insert it into the correct position in a sorted list. Okay, then return the sorted list and stop the execution. And now the similar pseudocode, that similar problems can be solved in using pseudocode. So first we are identifying from first element to the length of a is here nothing but, here in this algorithm they have taken array as in the name of a, and I will calculate until the data or the array elements exist in a, until that this loop will be going to be executed. That is, I is from 1 to length of a. So here I equal is represented in the form of arrow if you are developing the pseudocode. Okay, so here first thing what I will do, the ith element whatever that is there, that I will store in x, and then I will start with the second element, this is j is equal to 1, and while j is greater than equal to 0, you need to shift that element until the element from the list that you want to place in the proper order, until it will satisfy to place it in the exact position, until that this condition, that is while loop, is going to be executed. So while j is greater than 0 and a of j minus 1 is greater than the x value what we have stored, until then this operation execute, and this shifting, that is a can be shifted, a of jth element can be shifted from a of j minus 1 position to a of jth position. So it will be taking place. Once this one of the condition get false, then it will come out of the loop and it will decrement the jth value and jth index, and then it will go for repeating that. And once all the elements are in this position and it is able to place the value that is in x is in its exact position, then you're going to assign that value in the jth position where the location is empty. This is a procedure. So actually just I want to differentiate from how the algorithm and how the pseudocode is used. Okay guys, so now let me have the second part of my session, that is why actually the algorithm analysis is required. So here you are seeing this, the analysis of algorithm is a process of analyzing the problem solving capability of the algorithm in terms of time and size required. So analysis is required because the problem that I have developed in the form of algorithm, to know how much time it required to execute and how much size it is required in the memory, how much space it is required in the memory. So is if I try with the some other algorithm for the same problem solving technique, whether it will be efficient with the time and space or size required. If that is so, so I will go for the efficient one. No, the current one is also is better than the other one, then you will go for developing going to use for the current one. So like this, the researcher or the so what you will call it as discover inventor, what they will do, go on processing or go on inventing the new algorithm which will take the time and the size as minimum as possible than the existing one. So the main concern here of analysis of algorithm is nothing but to have a better performance and the time, less minimum time required for the execution. Okay, so now let me have so what are the different kinds or the types of analysis you are having? So worst case, best case, average case. What is this worst case, best case, average case? Worst case is nothing but, so if a problem is given to execute, it will take the maximum number of steps. So this maximum number of steps means what? Normally, so that will be there in the looping statement, inner looping statement. So the repetition, wherever the repetition there is there. So depending on that, the worst case analysis, best case analysis, average case analysis is done. So here the maximum number of repetition of the loops takes place while executing the particular instance of the problem or the size of A, or the particular list is going to be solved. Then that is called as worst case. So best case is nothing but minimum number of steps taken and any instant of size A. So that A is nothing but number of element in particular array list. And then the average case is nothing but in between worst case and best case. That means average number of steps is taken on the instant of size. So guys, I'm going to have a simple example of searching. Okay, so like that, so many different examples we can have for having the how this worst case, best case, average case analysis done. So for example, there are n elements in an array of A, that is A elements in an array of L or something list. So if I am searching for a particular value, okay, so it will take me the comparison of each and every element in the set of list until I will reach to the last element, right? So maximum time taken, last element. If that last element is matching, so the time taken until I have reached to the last element, or if it is not matching, for that also I compared all the key element with all the element in the list, whether that key element is exist or not. So there I have taken the maximum number, and then I will stop my execution, right? So best case, for the same list, if I am searching for the element that I appear or occur in the list L, for the first element comparison will be the successful, then only one time I'm going to execute the loop for the searching, and I will stop my execution because I got my element what I was searching. No need to go until the end, right? So that is a best case. Average case is nothing but, so in between in the list, this element that you are, or the key element that you are searching will be appear, or it is available in between in the some of the in between in the list of array. No need to no it will not there in the starting of the list, or it will no need to go until the end of the list. That is average number of steps. So I will try to have the videos, further videos about how the worst case, best case, average case calculation is done with taking the specific example. So now for your understanding, just I have done this video, friends. Okay, so the next thing is how the analysis is done. So to do the analysis, we need to follow the facts or the factors, right? So that factors is combined and it is formed in the form of analysis framework. So now the first thing, we need to compute the best case, worst case, and average case efficiency. Next, we need to measure the input size, and then we need to go for the running time, and then compute the order of the growth of algorithm, and measuring the space complexity and measuring the time complexity. So guys, I will start from uh, this content, so measuring the input size. So guys, here once you start executing the program, so first they will ask how many elements you need to include. That is n element, that is my input size, or sometime that is n square element, or sometime it is only one element, sometime it is only two elements, or depending on which type of problem you are solving. So depending on that, you need to measure the size of the input. So either 10 numbers, that is number of elements is n, or it is only two inputs, that is for the addition a and b, the input size will be 2. So like that. Okay, so then then you need to go for calculating, measuring the running time. So how to calculate the how to measure the runtime here? So guys, normally the runtime measurement we are going to be done in the program or the algorithm where actually the more times takes for the execution. So normally the more times takes in the looping statement, but if there is no looping statement, the assignment or the addition time, whatever it will take, right? So that actually the main measurement of the running time. As I told just now, that all this kind of implementation I will take an example in my next video, and I will explain you the concept of how it is the runtime takes, how it is the input size can be calculated, all those things, and then computing the order of growth of the algorithm. So guys, the order of growth of algorithm is nothing but, if n is equal to 4, the time taken for the execution, so once you start running it, it will complete and it will give you the output, it will take a 2 nanosecond. For example, if n is equal to 4, means only 4 values or the 4 elements are given in the list. In case the same algorithm is repeated for executing for the next time, and if you give the value n is equal to 16, so then it will take 4 nanosecond, right? So initially n was equal to 4, now n is equal to 16, means if the order of growth of this algorithm is, the time taken for 4 element was 2 seconds, and time taken for 16 element is 4 seconds. So the order of growth of this algorithm will become n square. So how this n square calculated? So again I will show you with an example in my next video. And next is measuring the time complexity. Time complexity is nothing but what I told you here, the execution of n is equal to 4 2 seconds, and execution for 16 element is equal to 4 seconds. So that complexity is also be calculated. And measuring the space is how much space is required to perform the operation of a particular problem in your memory, so that is also be calculated. And then you need to identify, so computing the best case, worst case, average case, efficiency. Okay, so guys, here the measuring the space complexity and measuring the time complexity is not possible, both are not possible in a single algorithm. So you should be aware of it. We need to compromise among this. If some algorithm is taking a minimum space, may take a maximum time. If some algorithm taking a minimum time, and it may take more space. So but what is our intention? We need to minimize the space, we need to minimize the time. Depending on that, we need to go for the algorithm development. Okay, and this worst case, average case, and best case efficiency that you explain how it is calculated in the previous slide. But one more thing, all the three will not be applied for all type of algorithm. For the searching, all the three is going to be applied, because depending on where exactly the key element I'm going to search, where exactly the key element available in the list, that can be done with three different cases. But in some or in other algorithm, any one of this condition, most of the time the worst case efficiency calculation is done in most of the algorithms. For example, sorting. For sorting, I should not expect best case and the average case, because the sorting of the element, all the elements has to be done in the list. So it will start from the first element and it will complete all the element comparison until it will reach to the end of the list, where it will take a maximum steps for the execution, so which is identified as a worst case, guys. So this is how we are going to analyze the algorithm. A particular algorithm is analyzed by covering all these steps, and that gives you the analysis of an algorithm. So why the analysis of algorithm is done? To perform well or efficient by the capability of taking a minimum time or the minimum space, right? So depending on which concept, either for the space or the time, you need to compromise with that, and you have to design an algorithm. Okay, so guys, I think this basic information about the necessity of algorithm analysis and the reason of algorithm analysis, and what actually the analysis of algorithm is very well explained here, best of my level. So I hope you liked it. So please friends, if you not yet subscribed, please subscribe the video, so that any further video uploading, so that notification you will get, and you will be having a very good information from this with the very best level. So like the video and share the video to your friends. Thank you guys. Bye bye.